All right, more basic tutorial today. In fact, I'll put this in the top as a comment. Pointers in C. What are they exactly? I'm just gonna do a very brief introduction to them, not go into that much detail, because there's a whole lot of things you can do with pointers, and there's a reason why they're so efficient and used so much, just so often in C, and just other programming languages. So we'll go ahead and just start with a little example. We're gonna take a regular integer, name it A, give it a value of 6, let's say. That is not how that's supposed to go. A equals 6. Now what we're going to do is declare another variable. This is going to be a pointer to an integer. And to show that, you have to put the star. We'll name it P for the sake of just it being a pointer. We've declared that. Now what I want to do is, well, I want it to point to the variable A. And how you do that is you take P and you assign it the value, the address of A. So let me explain what's going on here. The integer A has an address somewhere in memory, and that address holds the value 6. Now what we have is a pointer that once we set it equal to that address of A, it now holds that value, which is 6. So if we print F right now, %d, new line character, star P, when you're printing it, you have to include the star. And, sorry, that's from an old video. And then we compile it and run it. It's going to print the value 6, just as expected. But we're printing star P, we're not printing A. That's because P now points to that address of A. And that address holds the integer value 6. So what can we do with it? Is it just only useful for holding that value and printing it? No, you can do a lot more with it. You can change the value. Let's say we want 6 to become 8. We're going to do the star P again, set it equal to 8, compile, run, /a.out. It's now the value 8. We've just basically taken that address where the 6 originally was, and now we've changed it to 8. We're using the pointer. Now, you might be wondering, why is this more efficient than just say A equals 8 straight up? Because when we do that, we're creating a copy of A. We're creating two variables now. And that may seem insignificant. That's not going to cause you that many issues at all. It's just two small integers. However, it starts to mess with the memory. You're just allocating more memory unnecessarily. It's not as efficient as just having a pointer point to that address that can change that value. You're changing the value of A directly to 8 versus making a copy of the variable A and turning that into A while also having the original integer value. So there are a few ways that you can go wrong with this and cause issues. Segmentation faults, as they're called, which are memory issues. A segmentation fault occurs when the program tries to access some part of the memory that it can't access or is just unaccessible, unreachable, shouldn't be accessible. We'll give an example. I'm going to declare another integer, another pointer to an integer. And we're going to name it in C. Now down here, we'll take we'll just try and give it a value. C equals 10. Now, I'm going to do the same thing as above. Print new line, star C. And, surely it'll print 10, right? No. It prints the 8 as before. Then it gets here. This causes an issue. And then it causes a segmentation fault. Why is that? That's because you can't just set an integer equal to a value. You can't assign it a value. You need to have it point to an address before you do that. Just like what P is doing here. First, we're assigning it the address of A, then we can change the value. If you do this, then it leads to a whole lot of undefined behavior, causes a segmentation fault. Luckily, the computer is able to see this issue, and yes, it crashes right then and there, and helps you find out where the problem is. If you didn't know the problem was there, let's say I just removed that new line from this statement right here. It's no longer there. We're going to recompile and rerun. The 8's not printing anymore, but you might be a little confused as to why, because there is, it's the new line had nothing to do with the segmentation fault, right? And that's correct. It isn't printing because the way C does it, it has an input buffer from the standard in, it has an output buffer that's reading all this in. And when you put the new line there, it terminates that buffer. You can start putting new things in. But if there's no new line character, it's all in one buffer. So this segmentation falls in the same buffer as that. So this is not even going to print because it's just messed up by the whole memory issue and segmentation fault. That could help you debug. It's a print debug, which is a form of debugging. You're putting print statements to find where the code program went wrong, where it crashed, putting the new line in. It would go back. You'd see, yes, the 8 prints. Then the segmentation false. So it must be here. C equals the address of A, star C equals 20, semicolon, of course. There you go. Prints 8 originally, then the value changed to 20 at that address, and now it works just fine. No segmentation faults, no silent runtime errors. That is the basics of pointers.